Today we are solving physics. So our question says a block of mass 2.50 kg is put through a distance of 2.20 meters along a horizontal table by a constant applied force of magnitude of that is 16 newtons. Part 1. How much work is done by the applied force if theta is equal to 30 degrees? To find the work done by the applied force, the first thing that we're going to do, we're going to draw a free body diagram. So for a free body diagram, we show all the forces acting on an object. Okay, so the object that we're given here, it is a block. So here we have to show all the forces acting on this our block that we have. So number one, we have this force. So the force is being applied at an angle of 30 degrees. So the angle at which the force is being applied, that is 30 degrees here. So if this force is being applied at an angle of 30 degrees, therefore this force, it has two components. So number one, we have the y component and also the x component. So these are the two components that this force will have, because it is being applied at an angle. So we'll draw a straight line here. So this is the y component. So this is Fy, which is equal to F sine theta. Then we have the x component, which is here Fx. So Fx is F, that is cos theta here. So when you look at the direction of this block will be moving in the positive x direction. So it will be moving in this direction. So as it is moving in the positive x direction here, this block will have the friction force that will be opposing its motion. So the friction force will act in the opposite direction. So this will be the direction of the friction force. Then also we also have forces that will be acting on this block, that is along the y. So number one force, we have the upward force, which is what we call the normal force. And also we have the downward force, which is what we call the gravitational force, which is mg. So this is our free body diagram now. So to calculate the work done by the applied force, we know that here work is being done along the x. Okay, so what we're going to do is we're going to say the work done by the applied force will be equal to what? It will be equal to the force being applied, then we'll multiply it by the change in displacement there. Okay, so now this will be equal to what? So when we look at the force, this force is being applied at an angle. So therefore, we're going to use the force for the x component, because this our block will be moving in the positive x direction. So therefore, this will be F cos what? Theta. Then we multiply by the change in displacement, which is the change in x there. So now this becomes, the force being applied here is 16 what? 16 newtons. Okay, then we'll say cos, then the angle at which the force is being applied, you can see on the diagram, is 30 what? Degrees. Then here we're going to multiply by the change in position, which is 2.20, that is meters. So from here we have to get our calculator and punch so that we have our answer. So after punching, the answer that I'm getting is 30.5 joules. So this one becomes the work done by the applied force. Then moving to part 2. Part 2 says, suppose nu k, which is the coefficient of kinetic friction, is 0.2. So suppose nu k is 0.2. How much work is done on the block by the friction force? How much work is done on the block by the friction force? So here we need to calculate the work done by the friction force on the block. Okay, so the work done, that is by the friction force here, will be equal to the friction force itself, then times the change in displacement. That's what we're going to do. So the friction force, we say the friction force is the coefficient of kinetic friction, then times the normal force. So just substitute what is Fk here, we'll substitute with what? The coefficient of kinetic friction, then times the normal force. Then we'll multiply this by the change in displacement. So here we know the value for the coefficient of kinetic friction, and also we know the change in displacement. So what we need here is the normal force. So to get the value for the normal force, if you can see on this our diagram, the normal force is actually the upward force is along the y. So to calculate the normal force, we're going to resolve all the forces along the y, because that's where the normal force is. So number one, we're going to say the summation of all the forces along the y. So number one, we have the normal force itself, which is along the y. Then number two, we have this our force that we have right here. This is also along the y. So this force is positive what? That is F sine theta. Then we have the gravitational force, which is negative mg. So now, since there is no any work being done along the y, so therefore there is no acceleration along the y. So meaning that acceleration along the y is equal to 0. Even the net force along the y will be 0. So we put a 0 there, then we say this is equal to the normal force, then plus that is F, then sine theta minus that is mg there. Okay, and then from here what we're going to do is we'll make the normal force the subject of the formula. So the normal force will be equal to when mg crosses an equal sign, it will be positive mg, then minus what? F sine theta. So the normal force will be equal to the mass of the block is 2.50, then the gravity is 9.81, then minus the force being applied on the block is that is 16 newtons, then sine the angle at which the force is being applied is 30 degrees. So here the normal force becomes So the normal force becomes 16.5 newtons. So that one becomes the value for the normal force. So we come here, we say the work done by the friction force becomes the coefficient of kinetic friction, which is 0.2. Then we'll multiply this by the normal force, which is 16.5. Then we'll also multiply this by the change in displacement, which is 2.20 there. So when we punch on our calculator, 0.2 times 16.5, then we multiply this by 2.20. So the work done, we add the negative because that's the work done by the friction force will be in the opposite direction. So therefore it becomes negative 7.26 joules. So that one becomes the work done by the friction force. Okay, then the last part, which is our part 3 for this our question. So part 3 says calculate the total work done on the block. So here we have to calculate the total work done on the block, which is the same as the total net work done on the block. So to calculate for that total work done on the block, actually we're looking for the work done, okay, the work done by all the forces that are acting on this block. Okay, so say the total work done here will be equal to what? Number one, we say the work done by the applied force plus the work done by the, that is the friction force, then plus also the work done by the normal force, then plus the work done by the gravitational force, which is mg. So the total work done here becomes, the work done by the applied force is this one. So we got that is 30.5 joules. Then we're going to say plus the work done by the friction force, that's a negative. So it's negative 7.26 joules. Then plus the work done by the normal force. Remember, along the y there is no any work done, so therefore the work done by the normal force is 0, and also the work done by the gravitational force here becomes what? Is 0, like I've written there. So now we just need to punch now this our calculation. So I'm getting the total work done. So the total work done becomes, that is 23.2 joules. So this one becomes the total work done, that is on the block. Then we have our second equation, so which is our question number 2. So question number 2 says a block of 10 kg is put on an inclined plane with a force of 20 newtons. So we'll collect our data here. So the mass of the block is 10 watt kg, which is being put on an inclined plane as shown on the diagram there, with a force of 20 newtons. So the force being applied is 20 watt newtons there. Then the coefficient of friction force between the block and the plane, the coefficient of friction between the block and the plane is 0.2. So the question says calculate the work done by the applied force if it is put through a distance of 2 meters and theta equal to 20 degrees. So I have to calculate the work done by the applied force if it is put through a distance of that is through a distance of 2 meters, then at an angle of what? 20 degrees there. So to calculate the work done by the applied force, first we're going to do our free body diagram on this our inclined plane. So we have to show all the forces acting on this our inclined plane that we have. So we can see the force is being applied at an angle, and they've stated to say the force is being applied at an angle of 20 degrees. So the angle here is 20 degrees there. Okay, so that's the angle there, which is 20 degrees there. Then remember this force, when you look at the block, the way it is placed, it is placed on an inclined plane. So the angle of this inclined plane is 30 degrees. And remember, since this is an inclined plane, meaning that even this block, it will be at an angle. Okay, now also the force they've mentioned to say the force is being applied at an angle of what? 20 degrees there. That is up the inclined plane, meaning that this our force, it has the x and the y component. So when we do like this, so this side becomes the opposite, which is f sine what? Theta. Then for the x component we have what? That is f. Then we have cos theta. That's what we have there on that our diagram. Then also we have, yes, the normal force. Then the gravitational force is acting at an angle of 30 degrees, meaning that this our gravitational force, it has two components. So number one, it has the x component and also the y component. So when you look at this line for the normal line, okay, let me just show you here. This is the normal line. So where the normal line is ending, the angle that will be formed here, it will be a 90 degrees angle. So if we extend this our line, it goes like this. The angle that we are forming here, it is a 90 degrees angle. So now remember, always the adjacent becomes cos. Okay, so this is the adjacent that we have. This is cos. If you look at this where the force is being applied here, you can see that this is our adjacent. You have the angle theta here, and also 90 degrees there. So this side, it is what we call the adjacent. Then on the gravitational force here, when we also look at this our right angle triangle that we have, one, we can see that this our right angle triangle, this side that we have, this is 90 degrees. Then this side it is the angle which is 30 degrees. So this side becomes what? Becomes our adjacent, which is cos. So this becomes what? Mg cos what? Theta. Then this side becomes mg sin what? Theta. This is what we have on this our diagram. So the force is being applied at an angle, so it has two components. Number one, we have the x component and the y component. So as this block is being put up the inclined plane, we have the friction force that has been indicated here, which will be trying to pull this block down the inclined plane. Also in the y, we're going to have the normal force, which is the upward force, and also the gravitational force, which is also along the y, that will act at an angle. So therefore, this our gravitational force, it has two components. It has the x component and also the y component. So this is the y component, this is the x component, following the rules for trigonometry. So now to answer our question, which is saying we have to calculate the work done by the applied force. So that is part 1 here. So the work done that is by the applied force will be the applied force itself, then times the change in displacement. Okay, so remember, this our applied force, it is being applied at an angle. So we are going to use the x component because the movement will be happening along the x, so we can't use the y component. So it will be f. Okay, so it will be f cos what? Theta. So f, then e cos what? Theta. Then we multiply this by the change in position. So now this will give us the force being applied is 20 newtons. So the force is being applied at an angle of what? 20 degrees. Then we'll multiply this by the change in displacement. So it is 2 meters there. So we have to punch on our calculator again. So I'm getting 37.6 joules. So 37.6 joules becomes the work done by the applied force. So that one becomes the work done that is by the applied force. Then we have our part 2. So part 2 says calculate the normal force. So remember, for us to calculate the normal force is along the y. So if we know that the normal force is along the y, then we just need to resolve all the forces in the y, then we can solve them for the normal force. So say the summation of all the forces along the y. So number one, on this our diagram, we have this our normal force, which is the upward force. So the normal force, then also we have the y component for the applied force, which is f sine theta. So that will be positive what? F, then e sine theta. Then also we have along the y, also we have this mg cos theta, which is pointing down. So that one becomes negative, it is pointing down. So it's mg, then cos what? Theta. That's what we have. Then now from here now, since we know that there is no movement along the y, so the net force or the summation of all the forces in the y should be 0. Then the normal force, that's what we are looking for. Then E plus the force being applied is 20 newtons. So before I substitute, let's make n the subject of the formula. So I have plus, that is F, then sine theta minus, that is mg, then cos theta. Then now making the normal force the subject of the formula, we have positive mg, then cos what? Theta, then minus, that is F sine what? Theta. So the normal force becomes the Mass of the block is 10 kg, then gravity is 9.81. The force is being applied at an angle of 20 degrees, then minus, I'm so sorry, here this is for the gravity, okay? So this information, it is for the gravity. So the mass of the block, yes, is 10, then the gravity is 9.81. Then the gravity is acting at an angle of 30 degrees. So the gravity is acting at an angle of what? 30 degrees. So it will be cos what? 30 degrees. Then minus the force being applied is 20 newtons. Okay. Then sine, the angle at which the force is acting at is 20 degrees there. So we just need to punch for the normal force. So I'm getting the value to be 78.1 newtons. So that one becomes the normal force. So the normal force becomes 78.1 newtons. Okay. So that one becomes the value for the normal force. So now we'll keep the values that we found. So we'll keep the work done by the applied force just here. So the work done by the applied force that we have is 37.6 joules. Then the normal force that we have calculated is 78.1 newtons. We'll need this information. So now we move to part 3. So part 3 says calculate the friction force between the block and the plane. So to calculate the friction force, we say the friction force is equal to what? The coefficient times the normal force. Okay. So the coefficient is 0.2. Then the normal force, the one that we have calculated, which is 78.1 newtons. So we just need to punch that on our calculator. So we're getting 15.6 joules. So just need to indicate that this is a negative because that's the friction force. Then part 4 says calculate the work done by the friction force. So the work done that is by the friction force becomes the friction force itself then times the change in displacement. So the friction force is negative 15.6, that is joules. Then we multiply this by the change in position, which is 2 meters. I'm sorry, the friction force, the units should be newtons, not joules at all. It should be newtons. So this is newtons. So the work done by the friction force becomes the friction force negative 15.6, that is newtons. Then we multiply this by the change in displacement, which is 2 meters. So we just need to punch. We multiply this by 2. So getting negative 31.2 watt joules. So that one becomes the work done by the friction force. So can also indicate the work done by the friction force is negative 31.2 watt joules. Then also we found the value for the friction force to be negative 15.6 watt newtons. Then the last equation says calculate the total work done. So to calculate for the total work done, we say the total work done will be equal to what? Is the work done by all the forces acting on the block. So number one, it is the work done by the applied force, then plus the work done by the friction force, then plus that is the work done by the normal force, then plus that is the work done that is by the gravitational force. So the total work done here becomes, we have the work done by the applied force, which is here 37. So the work done there, that is by the applied force, is 37.6 joules. Then plus the work done by the friction force is here, which is negative 31.2 joules. So negative 31.2 what joules here. Then plus the work done by the normal force, since we know that there is no any work being done along the y, so the work done by all the forces along the y is 0. So the work done by the normal force is 0, then the work done by the gravitational force is 0. So here we have our total work done to be, so that's 37.6, then minus 31.2 joules, so I'm getting 6.4 joules. So 6.4 joules becomes the total work done by that's the total work done on the block.